Hi, in this video, my teammates and I will be explaining about B5G as enabling technology for building smart ports or harbour cities. However, before we get into it, let's begin by understanding what port is. In this case, the port is referred to maritime port. A port can be defined as a transportation hub for ships for the facilitation of cargoes or passengers. As ocean freight is one of the main transportation modes for the global merchandise trade, 90% of traded goods are transported by sea that passes through maritime ports. About 95% of Malaysia's commercial goods are transported on marine routes via seaport. Therefore, as a global supply chain has been rapidly increasing, it is important that the efficiency of maritime port is also being improved as time goes by. Since a maritime port is an essential location for shipping and logistics, through technological advancement can it facilitate higher efficiency for good transportation, service deliveries, and smooth flow of information. And with that said, the term smart port is used. Now, what is smart port? It means developing solutions to address the current and future challenges faced by seaports, including spatial constraints, pressure on productivity, fiscal limitations, safety and security risks, and sustainability. It is also an indication of a port that is innovative and in a competitive manner, typically in the sense of automations and innovations by implementing new technologies such as artificial intelligence, big data, Internet of Things, blockchain, and even 5G connectivity. In other words, maritime logistics will be fully integrated and monitored digitally based on real-time information that can be available from any devices. To sum it up, Smart port is created with the purpose of creating port systems that are more agile, flexible, and environment friendly. Now, let's get into our main point, starting with what is B5G. B5G stands for Beyond 5G and can be considered or comprehended as 6G connection even though 6G still has years from being fully developed. This network is said to be able to reduce various issues of the 5G connections. With the application of terahertz frequency band, B5G networks are able to increase their data rate from gigabit per second to terabit per second, reaching a peak transmission speed from 100 gigabit per second to 1 terabit per second. Some of the main characteristics of B5G includes ultra intelligence, ultra low latency, ultra wideband, and ultra spatialization.
Next, we'll look into what the implementation of B5G has brought to smart ports. The smart port can be divided into three different parts. The first part is smart infrastructure that aims to increase productivity and utilization of digital technologies such as sensors, cloud computing, and Internet of Things. Next is smart traffic flow, which enables optimal and efficient handling of the movement of assets. Lastly is smart logistics, which focuses on building port service systems to optimize logistic processes by improving port compatibility in logistic chains. To achieve better traffic control and logistics, the integration of smart infrastructure is required. An example of smart infrastructure is intelligent automation, which is the intelligent in controlling and monitoring of the end devices. The implementation of intelligent automation makes physical infrastructure and assets smarter, thus increasing the efficiency of the port and improving trade flow. Another technology that is adopted is virtual reality. It enables remote monitoring of port operations in real time via on-site video surveillance. The field operators can work efficiently as it allows them to visit the port in VR environment and receive remote assistance. However, large quantity of data processing are required, thus requiring higher throughput and reliable connection, which can be achieved by deploying 5G network slicing. The Port of Rotterdam is one of the world's leading ports that has adopted smart port technologies and systems. It uses digital twin technology, which is a computer program that uses real-world data to create simulations mimicking the port. With this, they can predict how a product or process will perform by seeing ahead of time how their activities will affect the port, the surrounding ecosystem, and the shipping industry, thus keeping the port running smoothly.
B5G is supporting the development of CAVs and help revolutionize the way goods are shipped and transported. Connected and automated vehicles, or short for CAV, has been a big part in helping to increase the development of smart port being a real solution to current problems. Smart ports hold the promise of increased efficiency and productivity. Automated guided vehicles, or AGVs, are extensively used in the maritime industry and are one of the most innovative components of a fully automated port. The pros of CAV: the increase in efficiency. Vehicles and equipment having automatic identification and detection of containers in the smart port will help ports increase handling capacity. GPS-based traffic monitoring systems that can track ships' movement and feed real-time info to ports, where they could monitor and provide best routes, effectively increasing efficiency. Number 2 is the reliable connection. These smart ports should run on a reliable wireless network. Data should be transmitted seamlessly without loss, latency, or jitter in the harsh port environment, and B5G enables this effectively. Number 3 is boost in productivity. More cargo can be cleared out in less time, which reduces load time, as CAVs can work 24/7 and does not need to meet human needs to continue working. And lastly, safer working environment. A safer working environment means accidents become less common as artificial intelligence and automation is more common, where AI can analyze data to make it a more risk-free environment for human workers. By replacing yard tractors and eliminating the need for a labor force to drive the tractors, AGVs are creating a rapid, economical, and safer container transport system within the port. The challenges of traditional ports before the implementation of B5G for CAVs. So the first one is limited production capacity. Old infrastructure, lack of resources, and lack of technologies has been proven to be a constraint as the global trades increased. SmartPort helps to address this as there is automation of vehicles as it allows containers to be processed more quickly. So for the second one, financial strain. Companies are unable to keep up with demands, and if without plan to manage resources adequately, they can mistakenly spend more on crews that end up working overtime as they wait for cargoes and manage them. SmartPort help to address by providing supply chain transparency where they can see all activities in a port to help better planning to avoid this and increase productivity and save costs. And for the third one, forced digitalization. Digitalization, new software, and advanced 5G networks only pose a problem for ports that have not yet adapted to new technologies. Port management that fails to adapt to these new technologies will not remain competitive. By becoming smart port, new technology solutions can be integrated into their organization, such as autonomous cranes and vehicles, advanced analytics, shared dashboards, real-time data, digital twins, enhanced maintenance, accurate predictions, and new digital solutions. And without first digitalizing everything beforehand, it could lead to multiple problems for new technology implementations.
So, what is the point of network security? For starters, we need network security to secure your data from malicious users and prevent them from gaining information about you. Secondly, we want to prevent malicious users from entering the network without permission. But most importantly, we must avoid any type of cyber attacks on the network, such as a DDoS attack, which might cause the network to shut down. So how can we secure your data from hackers? For example, we may use a widely known encryption technique known as an Advanced Encryption Standard, or AES for short. When comparing 4G and 5G, 4G utilizes 1 to 8-bit encryption while 5G employs 256-bit encryption. In the future, B5G may incorporate even stronger encryption, such as a 512-bit encryption or a military-grade 1024-bit encryption. But for the time being, 256 is the most powerful we'll ever need. You may be wondering, what's the difference between 128-bit and 256-bit, and whether or not it even matters. The amount of bits define the strength of the encryption, and if there are more bits, the length of the algorithm key is longer, and if the length of the algorithm key is longer, brute forcing the encrypted data takes longer. You will believe that if you have a powerful enough computer, you can just brute force the data given enough time. But brute forcing the data currently takes the world's fastest computer 10 to the power of 32 years. In comparison, the universe is around 13.7 billion years old, with the final star anticipated to fade out in approximately 100 trillion years. So brute forcing a single AES 256 encrypted data would take you 100 trillion years. By then, the universe is long gone. Of course, once quantum computers are widely available, we could simply raise the encryption key or develop a new and even stronger encryption technology. So, what more might we do to safeguard B5G network besides encryption? With increased transmission speed and data, we need, of course, to build an AI-based network monitor. If given enough training data, AI is capable of automatically detecting cyber attacks before they even begin, filtering out all of the bad users from the good. They are also capable of processing large amounts of data at a given time, allowing the network to scale up. Because the speed of the B5G network will be faster than anyone has ever seen, this would work in our favor, as we could potentially create a node in devices that simultaneously help in monitoring the network. This is to prevent any sort of data leak or network breaches they may cause harm when constructing a smart pod or harbor.
Let's have a look at enhanced communication and collaboration of beyond 5G that enables technology for building smart port and harbor cities. The first one would be bandwidth. The quantity of data that may be transported through a network in a given length of time is referred to as bandwidth. Bandwidth is commonly shown as pipe. The bigger the pipe, the more data that can be sent through it. With each generation of the mobile network, the bandwidth has grown considerably. The average speed of a 4G network is just 10 Mbps only. Beyond 5G networks will have average speed of 50 Mbps. This is approximately comparable to the amount of data that wired home broadband networks can send, and represents a substantial advance in mobile networks capacity to serve users that demand large amount of data supplied quickly, like ports. The second one will be latency. Latency is the amount of time it takes for a signal to go from a device to the network and back. It is an essential component for anyone who uses real-time communication services like video calls or remote operating equipment. It is sometimes referred to as ping time. Beyond 5G network typically have a latency of around 10 milliseconds. In terms of data transport speed, this puts it on a level with the human eye. The existing network's latency limits autonomous and remote operation of machinery such as trucks, cranes, and straddle carriers. Beyond 5G removes these limitations by allowing signals to be transmitted as quickly as if the equipment were managed by a human. Let's have a look at systems and devices of Beyond 5G, which helps to build smart port and harbor cities. The first one would be remote control of gantry cranes. A gantry crane in a port is about 30 meters tall, with the operator's cabin at the top. The most problematic aspect is that operator's cabin is located on top of the cranes, producing an unfavorable working environment. Remote control ensures operator comfort and increased port productivity, especially when utilized extensively. Remote control is enabled via installation of cameras and programmable logic controls. A gantry crane is required to upload 5 to 16 channels of surveillance videos in 1080p resolution. This requires a network bandwidth of 30 Mbps. As a consequence, beyond 5G's bandwidth and low latency can handle video uploads and reliable PLC communications, meeting such network requirements. The last one will be automated guided vehicles. AGVs are software-controlled container carriers. They have sophisticated surveillance cameras and 3D sensors. They also help with cargo loading, unloading, and transportation while moving freely and precisely through ports. Beyond 5G networks makes these applications more accessible. If an AGV becomes trapped in the working field, for example, the operator can use onboard cameras to learn about the environment, detect difficulties, and remotely command the AGV to move it out of the target area.
Now, let's move on to the networking aspects of B5G. The first aspect is within the physical layer. B5G networks are generally anticipated to produce over-the-air speeds of greater than 100 gigabits per second. This will require moving beyond millimeter waves capabilities and into the terahertz band in order to be accomplished. The network will depend on wideband allocations in this frequency spectrum. This type of access is easily taken into account for backhauling B5G networks. In B5G networks, massive and dense MIMO are essential, particularly if terahertz is enabled. Specific technologies including metamaterial-based antenna, reconfigurable intelligent surfaces, and orbital angular momentum transmission may serve as the cornerstone technologies for the B5G radio interface by allowing for holistic resolution to the physical layer restrictions. The development of the amplifier and forward relay is represented by the radiology information system. To regulate the quality of the signal at the receiver, they insert an agent of change into reflective surfaces. These surfaces should ideally have high resolution and accommodate prompt and optimal control. However, whether in operation or fabrication, resolution and reconfiguration parameters have upper bounds. These surfaces are anticipated to still permit the gains required for terahertz communication in B5G. The B5G radio interface is anticipated to support true full duplex wireless in order to achieve additional improvements. Due to recent developments in self-interference cancellation, full duplex wireless is expected to provide significant spectral efficiency benefits. When used in conjunction with the recently developed non-orthogonal multiple access, it will also offer further benefits. To take advantage of these technologies to their full potential, cross-layer interactions must be made. Moving on to the next aspect, it is the congestion control. Effective congestion control, which enables the routing of numerous network instances by operators on the same arrangement for greater service superiority, is one of the key features of B5G technology. Artificial intelligence and machine learning are necessary to reconfigure and improve a B5G technology routine due to the massive data volume. Congestion in B5G networks can be managed by using machine learning to networking systems. Machine learning is expected to operate when used to solve complex problems, which will significantly influence future communications. To handle the demands of 5G Internet of Things networks, machine learning is a realistic and universally applicable solution combined with conventional congestion control technologies. Traditional congestion control systems can use machine learning as a viable and appropriate alternative to fulfill the needs of 5G networks. This uses predictions based on deep learning and naive Bayes to enhance congestion control.
The last networking aspect of B5G is the networking. B5G networking is expected to have excellent flexibility at both the link and networking layers, as well as a wider use of IPv6, if not beyond, which can grow to a more dynamic and reactive communication. Unquestionably, the control data split that the Internet softwareization introduced is a step in the right direction. There are additional factors to think about. For instance, more advanced link layer management modes are required due to advancement in the physical layer and topology. The multiplicity of connection possibility at the physical layer, on one hand, necessitates structuring and scheduling. On the other hand, in order to achieve greater performance levels, there is a requirement for closer interaction with upper layers that is a stronger cross-layer coupling. Additionally, Greater connectivity for Internet of Things or machine-tapped communication is a factor for both. Similarly, modifications are required at layer 3 to manage the increased connectivity from virtualized instances as well as physical and logical entities. Meanwhile, high-precision networking, where low to zero tolerance is used to certify service delivery objective, will need to place more of an emphasis on reliability. If appropriate support is to be given for URLLC services and their evolution, then these extensions are unavoidable. In conclusion, B5G allows technological advancement in maritime ports, allowing the efficiency on shipping and logistics to be increased with certain development growth of solutions to tackle issue experience. This is all from us. Feel free to comment or even question us. Thank you for watching and have a great day.